for our today's classes, we are going to do lab. We will take one autonomous system here, maybe 3 routers connecting to multi-homing scenario that connects to some other autonomous system, maybe 1 or 2, like this. With this we can test attributes, and we can tune an attribute and take different path than the default path. Right, so for that, let me build the topology first. I'm going to use the existing topology, which is similar but slight alteration may be needed. So the similar topology is this one. Look at this. It's almost similar. Only thing is I need to add more routers here. Yes, we got at least 3 routers. So let me add 2 more routers here. This one is okay here. Same subnet, no alteration needed. And I'll take 2 more routers. 1, 2. Let me pick fast Ethernet. Yeah. So this is our new topology. I'm going to remove the IP address from router 1 and put it on router 6. Start. So I also encourage you to do similar labs at home. You may copy a topology from our video or now from the class. It's up to you. 17.0.0/16. Yeah. So this is our final topology. As I said, I need to remove the IP address of R1's gig 4/0. show IP interface brief. This IP address is no more needed here. We don't have this /0 on router 1. This is supposed to go now on router 6. So let us go to router 6. From here I want to remove G4/0, no IP address. I also want to shut down. And on router 6, I'd like to paste this on G3/0. Interface G3/0 IP address is this 255.255.0.0. See? This interface IP is what I just finished configuring. /16. Alright. So next is I'm going to remove the BGP from R1 completely and redo it. We are going to redo, because there is going to be changes. Now we have more routers now. So on R1, no router BGP 1000. Let us not remove from 2, 3, 4 and 5. Let's not remove that. Let it be there. It's the same configuration. We should not repeat the same thing. But router 1 has got some new neighbors, so I am removing BGP. No router BGP, sorry, there is no BGP in this. It's a new router where we have to put BGP. Next, you see, if you want to form neighbor between loopback interface, what is needed? Routing is needed. Do you agree? We need to reach these loopback interfaces. Only then BGP can negotiate and bring the neighborship. So I'm going to run a common routing protocol. What protocol should I use? Someone tell me. OSPF. Do I need to run this OSPF on 3/0 on this router 1 and 6?
No, for internal.
Not necessary. It's only for internal Ibbgb. For Ibbgb to learn each other, we are using this IGP protocol OSPF. Fine. Let us now do that one first. Let us do router 7 configuration. I will use a notepad. Interface loopback 0 IP address 7.7.7.7 255.255.255 IP OSPF 1 area 0. Interface F0/0 no shared IP address 10.17.0.7 255.255.0.0. Interface F0/1 now shared IP address is going to be 10.16 0.7 0.0. That's it. And write to memory. So this I'm going to paste it first. Before we enable BGP, we need this. I'll put it on router 7. It's done. Next, for router 1, we already have the configuration. I need to just put OSPF. We already have what configuration? We already have the IP addresses in place. So only the OSPF. So what I'll do is I'll use enable config t interface loopback 0 IP OSPF 1 area 0. I don't know whether loopback interface exists, so let's create interface IP address 1.1.1.1 IP OSPF 1 area 0, and then interface F00 is a new interface, so we have to put the IP address 10.17.0. let's say 1. So what is this? Sorry, 1.255.255.00 IP OSPF 1 area 0. The other interface G3/0, there is no need for IP address. I just put there is no OSPF also needed. And right to so that's all. This is for router 1. Am I doing right? Yes, this is correct. This is for router 1. Oh no, all got selected. Router 1 is also ready. Now I'm expecting neighbor between 1 and 7. Shortly it will come. See, it will say neighbor 777. I'm expecting that. OSPF should say neighbor 7777. Show IP OSPF neighbor. What? Show IP interface brief. Ping 10.17.0.7. Aha. It's pinging, then why? Show IP OSPF interface brief. Okay. Show IP OSPF neighbor. What is this? We got OSPF running on F00. What about router 7? Show IP OSPF interface brief. That's the problem. I have not put the OSPF. I forgot to put OSPF on router 7. Done. So now the neighbor should come. See, the neighbor has come. 7 has formed a neighbor with router 1. Let's finish router 6. Router 6 is totally a new router, and we already configured G3/0. We need to configure rest of the interfaces. So router 6, F00 will have 67.6 and G3/0. I said we already gave IP address. I need to just nothing actually. We don't even run OSPF. They're not necessary. Okay, finish. So router 6 is having enough of OSPF. Done. I'm expecting a neighbor between router 7 and 6 now.
Seven sir, 80/1 not up.
Oh really? Show IP interface brief. Oh, on router 7 you said, no?
It is not configured, the 80/1.
Okay, let me try 10.67.0. What you said is correct. On router 7, show IP interface brief. No, Arindram, it is there, but
It is not configured.
no, it's a wrong address. That's what. Here it is 67 I mentioned, but here I have given 16.
16.
Interface F0/1 IP address 10.67.0.7. That's the problem. So now ping 10.60. See, neighbor has come. Alright, so we got neighbor. Definitely the ping will happen. Show IP OSP of neighbor. We have neighbor. Two neighbors, router 1 and router 6. So router 7 should ping 11111 with the source of 7777. And I should also ping 6.6.6.6 with the source of 7.7.7.7. It is pinging. What is next? Next is BGP. See, from router 7 we are going to have Ibbgp using loopbacks. Focus those who are not comfortable with basic BGP. Focus now, you will become comfortable. I'm doing from 0 level of BGP. Router 7 is in autonomous system 1000. So I say router BGP 1000. Sorry, not 100. I have to remove this. Router BGP 1000. Neighbors. Not network command, neighbor command. Neighbor 1111, which is router 1. Remote AS is the command for both Ibbgp and Ibbgp. So remote AS, what? 1000. Likewise, I got neighbor 6.6.6.6. Remote AS 1000. What is the other thing that I have to do? I have to source all my BGP packet from this address. Why? According to router 1, 7777 will be the neighbor address. So I have to source all the packet to these neighbors from my loopback. So I have to say neighbor 1.1.1.1 update source loopback 0, neighbor 6.6.6.6 update source loopback 0. Finished. There is nothing more to configure here. If you want to advertise the network, then you use the network command and advertise. I'm not willing to advertise that 111 any network now. I'm not willing. Later, if it is necessary, we'll do. Just for forming neighbor, these are the necessary commands. First command is to say who the neighbor is. Second command, when you speak to that neighbor, what should be the source address? The source address need to be 7777. So that's why I say update source loopback. Right. Router 7 is ready with necessary BGP. Let's go to router 1. Kindly focus, I have removed BGP from this router. Show IP BGP, see there is no BGP. Let's put BGP. Router BGP 1000. First of all, I want to finish Ibbgp. Neighbor. Ibbgp neighbor address is 125.12.0.2. Remote AS is 1000. another neighbor. Okay, listen. For this neighbor, you no need to say update source. Why? Because we are not using loopback address to form neighbor with Ibbgb. We are using the directly connected physical interface address. Why? Because I don't have to. If you will use loopback to loopback, what is the use? Between R1 and R2, if you use loopback, what is the use? You have only one link. If that one link goes, you cannot reach the loopback. Only when we have multiple paths, we use loopback. The reason why we used in Ibbgp is, the reason why we used loopback to loopback in our autonomous system 1000 is, in real network, there will be a connection even between R1 and R6. So there will be always redundant paths. If one physical link goes down, there will be another path via router 6. Another reason is we already have IGP reachability using OSPF. So I would like to make use of that reachability to form neighbor. But between R1 and R2, there is no routing. So you don't have reachability between loopback of R2 and R1. Better use the physical interface address. Anyone has got any question?
No, that only one thing is router 1, you put remote is 1000. It should be 2000.
Oh, thank you so much for that correction. Yes. Remote AS should be 2000. Next. Router 1 has got a neighbor called 7.7.7.7. What is the remote AS for 7.7? It's the same Ibbgb. To this neighbor 7777, the source should be from the loopback. Done. Yeah. So similar configuration we need to do on R6. Let's go to R6. Router BGP 1000. Neighbor is 7.7.7.7. Remote AS is 1000. Neighbor is 145.14.0.4. Remote AS is 3000, 4000. See, it's 4000. One more thing is, whenever you form neighbor using loopback, you need to say update source. So I did not say that. I'll say update source loopback.
Without update source,
okay, see, this is a very late question. We have covered these things very long back. When you form BGP using loopback, you remember BGP is a TCP based protocol. If you configure update source loopback 0 on one side, it will use the loopback interface and go and talk to the next neighbor, and next neighbor will reply to the loopback interface and form neighbor. But it's a good practice to do it on both the side. If you do it on one side, the neighbor will come up. But you should not be happy with that. You have to do it on either side. Next. We have Ibbgp now. See, R6 should have two Ibbgp neighbor. Show Ibbgb summary. We have two. No. Sorry, R6 will not have two because one is Ibbgp. We have not turned on router 4. I mean R7. R7 should have two Ibbgp neighbor. Show Ibbgb summary. You see, you have two Ibbgb neighbor for last 2 minutes 53 seconds. Router 1 is a neighbor. Router 6 is a neighbor for last 2 minutes and 1 second. You should not have where did you see? We should not have something like this. This is not a good sign, which means it is actively working very hard to find the neighbor. The neighbor has never come up. It is still actively looking for this neighbor. Why? Because it's off. Let's bring it on. Same status with R2, R1 also. If you check R1 routing table, even here, show Ibbgb table, show Ibbgb summary table. Here it says, I have a route 125.12, but I'm not able to ping this address .2. So it is in idle state. It will be switching between active to idle, active to idle. That's not good. Neighbor has never come up. It's all because it is not on. So let's bring it on. We have given enough time. By this time it should have booted. Let's check. It's booted. Okay. Now if I'll take you back to router 6. Earlier it was active and never, but now I should see it is up for last 1 minute and 4 seconds. Likewise on R2 I should see earlier it was idle. No, not R2, R1. R1 earlier it was idle. Now I am expecting up for 40 seconds. Good. So we got this autonomous system 1000 ready. Let's bring up R3 and R4 now. Right, R3 and R5 is ready. Once it is fully loaded, we should be learning routes. Show IP BGP summary. See, as of now, I have not learned any routes from these two neighbors. What is this PFX RCD? Can someone say what it is? PFX, prefix received, network received, nothing. Right, I'm expecting here 1. Because I remember on the other day I have advertised this network on R5. Let me go and check that now. R5, where are you? Show IP BGP. No advertisement. Show run section BGP. They have not advertised. Show IP BGP summary. Okay. Oh, here it is. We have advertised. We have advertised with a mask. Show run interface loopback 0, loopback 55. Yeah, this network we have advertised. Same mask. Let us check now. Show IP BGP. Yeah, it's advertising now. It took some time. It's local origin 000. But let us go to router 7 to see that. I'm in router 7. Look at this. Earlier it was 0, but now it is 1. What does this mean? This means there is one network, one prefix received, one network learned. And what is that network that is learned? Let's check. Show IP BGP. See, show IP BGP summary will show you the neighbors and all this information. To which autonomous system this router belong to which autonomous system these neighbors belong to, how many packets are sent and received so far, how long it is up, how many prefixes learned, all those info. But show IP BGP will show what all the network you learned. You see from both the neighbor, see this 11111, who is that? Router 1. From both the neighbors I have learned this. But it is not showing I am learning. Is it router 1's address? No, it's router 2's address. Why? Because BGP is autonomous system by autonomous system protocol. The next hop will be the address of the Ibbgp. The Ibbgp's address is carried into Ibbgp. Hope you remember those things. That's the next hop behavior. Here also this is an Ibbgp address, router 4's address. It is carried into Ibbgp and you see that in R7. You see? Now, is this address reachable from router 7? No way. It's not reachable. An unreachable next hop. An unreachable next hop. We can do this. We can fix this in two ways. One, run OSPF. By running OSPF on this interface, this network will be advertised and this ping will happen. But we don't do that in the production. BGP carries this interface address inside Ibbgp. That has become a problem here. Because these addresses are unreachable, R7 is showing this network as valid, but it is not seeing it as a best route. If it is not a best route, route cannot be uploaded to the routing table. The route will not be given to the routing table manager. So what do I have to do? We have to use next hop self command. We need to tell router 1 to put its own address. Instead of carrying Ibbgp address, we need to ask router 1 to put its own address as the next hop. Right now, if you type show IP route, you don't see any route to reach 55 network, do you? It's supposed to come through BGP. Show IP BGP. See, BGP has learned it. It has learned it through two paths. One via 4000 path, which is this route. How many hops? 4000, 5000, 2 hops. 4000, 5000, 2 hops. The other one via 2000, 3000, 5000. Tung, tung, tung. 3 hops. Right now, both the paths are not considered. Why? You remember the 0th attribute. You need to have a valid next hop. None of this next hop is valid. Let me open and show you that. You see, we learned the sequence. We learned the sequence. First is what? valid next hop. We don't have any valid next hop here. No valid next hop. Both are unreachable next hop. Try pinging from here, it won't ping. Yeah, it's not pinging. So what we have to do? Either you run OSPF on the WAN interface or make R1 and R6 to change the next hop. That's what I'm going to do now. I'll go to router 1 and tell router 1 router BGP 1000. I'm telling router 1, whenever you speak to your neighbor 7.7.7.7, just put your own address as this, your own address as the next hop address. Likewise, I'll go to router 6 and I'll say router BGP 1000. Whenever you speak to 7777, put your own address as the next hop. After you do this, R7, check the table now, show IP BGP. You see the next hop has changed. This will also change shortly. Now this is not changed, so still it is taking the long route. You see, it's a long route. But when this is changed to 6666, it will change, get changed. Now you see, look at this. When this was not reachable, it was going via this reachable next hop, a long route. See, greater than symbol. But when this changed to router 6 IP address, from router 4 IP address to router 6 IP address, which router 7 can reach, this has become a valid now. Why it is valid? Sorry, this has become best, not only just valid. Why it is best? Because of the less AS. Listen. When you see the order of iteration, first it will see whether the next hop is reachable. We got now both the next hop as reachable. This can ping, this can also be pinged. You want to see? Ping, pings. Ping, pings. Both can be pinged. So if that is a tie, it is going to check the weight attribute. Weight is also same for both the path. If that is a tie, then it will check the local preference. Local preference is also a tie. So it will go and check whether any network is locally origined with the next hop 000. If you have 000, it would have preferred that. But unfortunately, we don't have this network locally on this router 7. We don't have 7 router with 55 network in any interface. So cannot be. This is the tiebreaker, shortest AS path. You see, this is shorter, longer. Shortest AS path is via router 6. It is taken. So now if you check, show IP route BGP, you have the route to reach 55 network via 6.6.6.6. Router 6. See the topology? Router 6 is this way, this one. It will go to router 4 and it will go from router 4 to router 5. So we got the routes via router 6. And I told you the reason why it is not going via router 1, because of the long path. Okay, listen, one more thing I want to explain. If I go to router 1, show IP route BGP, it's going via router 2. Why it is going via router 2? Is it not a long route? Yes, it's a long route. It should come via router 6. So, even though it's a long route, why router 1 is taking the long route? Because router 1 do not know the short route. Who should inform router 1 the short route? R6. Will R7 inform? No. You remember? Route learned from an Ibbgb will not be given to another Ibbgb. The route that was coming like this, was given to 7, but 7 did not give. So router 1 do not know about this short route. What have to be done? Can someone say? Full mesh, right? I need to form neighbor with 1 also. We just form neighbor only with 7. Likewise, router 1 should form neighbor with 6 also. We just form neighbor with 7 only. Or there is another method. There is another.
It will not work, right, sir?
What?
Still, if we build a neighborship with R1, R6, Ibbgb, still it will not work.
It will work.
It is 200, where it is running by 20.
What you are saying? It will work. If you form, see, we already have neighbor with this. Now you form neighbor with this, directly it will give you the route.
But that route will be about 55 meters. That will be by 200, right, sir?
What 200? 2000 you mean?
No, 200 Ibbgb AD, right, sir?
No. Don't worry about that. You are confusing yourself with that. That's not the story.
Okay.
That's wrong. The 200 will come into picture only when we have OSPF, EIGRP, those autonomous system with comparison takes.
No, between Ibbgb and
Between Ibbgb, it is always 200 within this. Listen, the attribute. His question, Arindram's question is very nice question. But the problem is Ibbgb path is preferred over Ibbgb comes only at the 7th in the list. You understand, Arindram?
Yes, sir.
So it will not match now. Only when there is a tie in this first 6, Ibbgb 20 is preferred over 200.
Okay.
So don't worry about that now. So actually I was trying to teach something new now. Please focus. We learned we have to make full mesh. Otherwise 6 cannot give the route to 1 and 1 cannot give route to 6. This is very old, early day story we learned. If you don't understand, you have to go back and revise. Seriously. Now, there is another way. Router 6 has already given the route to 7, but 7 is not giving to 1. Simple. Go to 7 and say, router 7, give it. Instead of you forming another neighbor, another session, another update, you go to 7 and say, router 7, it's okay. Router 1 is your client. Consider him as a client. Give it to him. Let us see that. Let me do and show you. Right now, when I take you to router 1, you don't have route coming from router 6. Do you see any route coming from router 6? No. But when I go to router 7 and say router BGP 1000, you got a neighbor called 1.1.1.1. He is route reflector client, meaning you're supposed to reflect the routes to this client. After you say that, you go to router 1 and see now. You see the magic. You got another route. Earlier, we were seeing only route from this one, which was a long route, and the packet needs to go via the long route. But now you got another route given by R6 via Ibbgp, which is very short. So it prefers this path over this path. Why? Even though it's an Ibbgp, it prefers this path over this path. Why? Because of the AS. In the list, AS comes first. Shortest AS comes first. Ibbgp preferred over Ibbgp is not before that. See, AS comes first. Ibbgp preferred over Ibbgp is coming on 7th attribute. So, earlier router was not showing this shortest path, but now if I check show IP route BGP, I should see the route via router 6. So router 1 will now take this turn, U-turn, and go this way. It will not go via router 2. See, the next hop address is not router 2. It's the address of router 6. Fine. Up to this one, you do. I did not configure any attribute. I just showed you the default. I explained you the topology. Understand this topology very well and come. So that when I do the attribute, you will be in sync. Otherwise, you will be out of sync. Understand this topology. Check where, who is connected, what IP address is given. And so that when I speak, you will understand.
Sir, I have one question. Sir, when we put next of shell on the R1 and R6, sir, can we show, sir, please show IP route? Because I want to see.
Where do you want to see the route?
R1.
Which network route you want to see? This is R1 routing table.
No, sorry, R7, sir, sorry. R7 only show IP routing, not BGP table. Not BGP, sir, only show IP routing. Okay. No, because sir, I was thinking, sir, when we put next of shell on R1,
it will show the router ID with which you formed neighbor as a next hop.
Correct, sir. Well, I'm thinking, sir, it will, because it started learning about 125 network, right, sir? That's the reason it is, because that hop is reachable for router 7.
Yeah.
So I was thinking, sir, 125 also see in the routing table.
No. That's unreachable. No, that's why it was not using it earlier. When you say next hop self, it becomes 1111 or 6666.
Okay. But it will not see, show the 125 or
No.
140.
It neither says 145 or 125. It neither says 10.17 or 10.67. It only says the neighbor address as the next hop. Usually, some routing protocol, when they advertise, you see, they show their exit interface address 10.17.01. But it is not showing that address. It shows the address with which you form neighbor. Is it clear?
Yeah.
This is very important fundamental. Those who understand, I appreciate. Those who didn't understand, listen to this video once. If not, twice. Till you understand. Come to next class. We'll continue this. Thank you for joining today. Have a great
Thank you, sir.
day.
Thanks a lot.
Bye-bye. You're welcome.